Okay, so today we're going to do learning target 9. We're going to simplify radical expressions using properties of roots. So first things first, let's look at our properties of roots. So addition of radical expressions, this is the same thing of adding, and it would also be subtracting, but we're just going to stick with adding square roots. So if you look here, a times the square root of x plus b times the square root of x. These are both x's, which means they have to be the same number. So we can just add the a and b, our front term, and we still have our square root of x. So for example, we can have 3 square root of 5 plus 2 square root of 5. In this case, my x is 5, so they're both the same. So then I can add my 3 and my 2. 3 plus 2 is 5, and I still have my root 5. Multiplication. So what this is saying is that I take my a and my b and I multiply them, and I take my x and my y. So this is when they're different. They could also be the same. So in this case, if I have, it would be a times b, x times y. So 2 root 3 times 3 root 5. 2 times 3 is 6. 3 times 5 is 15. I just want you to notice this one right up here, you can only do if the number under my radical is the same. This one, they do not have to be the same. Division. This is where you have a radical divided by a radical. You can switch it. That's only if it is divisible. So like this, we can do 20 divided by square root of 5. 20 can be divided by 5, so we can do this. 20 divided by 5. 20 divided by 5 is 4. So now I have the square root of 4, but the square root of 4 is the same as plus or minus 2. And that would be my final answer. I'm going to show you how to do a problem like this if you cannot actually divide it. I'm going to show you how to simplify. But in this case, our x has to be greater than or equal to 0, and y has to be greater than 0 because we can't divide a number by 0. Like 0 can't be in the denominator, otherwise it doesn't work. So let's actually look at some problems. So here we have addition. My roots are the same, so I can add them. So I do my 2 plus 5. I'm going to get a 7, and this stays my root 3. Here I have multiplication, so I'm going to do my 3 times 2, and then I'm going to have my root 5 times my root 7. So this is going to be 6. I can just multiply them here. So I'm going to have 6 root 35. So here, 15 can be divided by 3, so I'm going to just do this. 15 divided by 3. 15 divided by 3 is 5. The square root of 5 is an irrational number, so I'm done. This is the simplest form that I can get. I cannot take the square root of 5. I'm done. So here, this is just distributing, except we're distributing a square root, or a cube, whatever. So I have 5 root 2 times root 3 plus 3 root 3 times root 3. So remember, this is going to be 5, 2 times 3, which would be 5 root 6, plus this is going to be 3 times 3 times 3. 3 times 3 is square root of 9, but what I notice here is I know the square root of 9. And I know that that is 3. So this is going to be 3 times 3. So then I'm going to have 5 root 6 plus 9. The other thing is, though, it could be a plus or minus 3. So this could also be 5 root 6 minus 9, because this could be a positive or a negative 3. So when I multiply by a positive, I get this. When I multiply by my negative, I get that. Normally, you'll see it written with the regular number by itself first, and then the radical afterwards, like that. So this is where I wanted to show you. This isn't on your actual note sheet, so just turn it over or find a blank spot of how to simplify radicals. So just say I had something like this. Square root of 80. I know that that can't be anything because the square root of 81 is 9, right? 9 squared is 81. This is 80. And then 8 squared is 64. So I know it's going to be between there, but I can still simplify this. I can think of numbers that multiply to give me 80, just like this could have been, right? 10 times 4. 10 times 8. But I don't want to use 10 and 8 because those aren't perfect squares. I want to use something like, I want to have the number 9 in there because 9 is a perfect squared. Or I want to have like numbers that are perfect squares. So like 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. So I want to have somewhere that. And I know that I can do 4 times 20, right? 4 times 20 is going to give me 80. 4 is a perfect square. So I can split this up now. I can just go backwards and make that this. So now I know the square root of 4 is 2. So now I have 2 root 20. But guess what? I'm not actually done. I can still simplify square root of 20, right? Can't this be 4 times 5? So now I have 2 times the square root of 4 times the square root of 5. The square root of 4 is 2, so I'm going to move this over here. Square root of 4 is 2, so I'm going to have 2 times the square root of 5. So I actually end up with 4 root 5. So that's how we simplify. So like a fraction that doesn't work. So just say I have a fraction of, I don't know, square root of, I don't want to use 20 again. Let's do the square root of 40 divided by square root, something that doesn't work, 3. 40 cannot be divided by 3. So I don't want to set this up like this because that's going to be a decimal and I don't want to deal with decimals. So all I'm going to do is simplify this. I can't simplify the square root of 3 anymore, so I know that that's going to stay square root of 3. But the square root of 40 I can think of as 4 times 10, which is the same as square root of 4 times the square root of 10. Square root of 4 is 2, square root of 10. So now I have to think, can I simplify the square root of 10 anymore? I have 2 times 5, neither of those are perfect squares, or 10 times 1, and neither of those are perfect squares. So that would be my final simplified answer. This is a time, so it would just be 2 root 10 all over root 3. So before class, create and solve 3 problems, 1 for each operation with radicals, addition, multiplication, and division. And we're going to go over that in class tomorrow.